Good day, everyone. My name is John Jericho R. Jose from BIT2K, here to explain to you the things you need to know about engine temperature sensor. But first, what is a engine temperature sensor? A coolant temperature sensor is used to measure the temperature of the engine coolant. The readings from this sensor are then fed back to the engine control unit. This data from the sensor is then used to adjust the fuel injection and ignition timing. On some vehicles, the sensor may be used to switch on the electronic cooling fans as well. The data may also be used to provide readings for a coolant temperature gauge on the dash. Where is a temperature sensor usually located? The coolant temperature sensor will be located directly behind the coolant pipe. In most modern cars and vehicles, this is present behind the right cylinder head that is located right underneath the air intake pipe. Some are near the thermostat in the cylinder head or thermostat housing. Many vehicles also have a second ECT sensor on a different part of the engine or radiator. What does an ECT inform to an ECU? When the engine is cold, the ECU adjusts the fuel mixture to be richer than normal to prevent the engine from stalling and stumbling. When it's warm, the engine gets a leaner than normal fuel mixture to maximize fuel economy while releasing the lowest possible exhaust emissions. The ECT sensor is a high authority sensor whenever the engine is cold because ignition timing is tailored according to the engine coolant temperature. It also provides input for idle air control, position, oxygen sensor, closed loop status, on-off times for the canister purge, and idle speed. Some vehicles, like those from Chrysler and General Motors, have a step-up resistor that broadens the ECT sensor's range. This extra circuit gives the ECU a more accurate engine coolant temperature reading compared to having one circuit. It also plays a huge role in maintaining your engine's life because it also monitors the temperature of your engine, and like a thermostat, it tells the ECU if the engine is at optimal running temperature or overheating. If the ECT sensor sends the wrong signal to the PCM, the engine is hot or cold when it's not. The computer can produce an incorrect air-fuel mixture and cause the engine to consume too much fuel. Hard starting engine. The ECU relies on the ECT sensor to control the spark timing and the amount of fuel to be injected into the engine. So if the sensor fails, you could have a difficult time getting the engine to start. Overheating engine. In most vehicles, the cooling fan uses the same sensor as the one on the engine coolant, which means it also relies on the ECU for input. If the ECU receives the wrong signal from the ECT sensor, it can stop the fan from working and cause the engine to overheat. Rough idling. An incorrect fuel mixture due to a faulty ECT sensor can cause the vehicle to have a rough idle. Illuminated check engine light. Any problem with the ECT sensor and its circuit can trigger the check engine light. Black smoke emission. A faulty ECT sensor can cause the ECU to produce a richer than normal fuel mixture as the excess fuel burns inside the tailpipe. It might produce thick black smoke. Trouble codes related to a faulty ECT sensor. A problem with the ECT sensor can cause the ECU to log a diagnostic trouble code DTC. Here are the most common ones that a scan tube might recognize. P0116 code. Engine coolant temperature sensor 1. Circuit range performance. This DTC is triggered by the ECU after it detects that the voltage signals relayed by the engine coolant temperature sensor falls outside the normal manufacturer specific range. P0115 code. Engine coolant temperature sensor 1 circuit. This code sets when the ECU detects erratic or irrational input signals coming from the engine coolant temperature sensor circuit. The code may also register if the ECU detects an abnormally low or high voltage signal from the engine coolant temperature sensor circuit. The one portion of the code points to sensor number 1 in vehicles with two coolant temperature sensors. P2185 stands for Engine Coolant Temperature Sensor 2, High Circuit. This code sets when the ECU detects an electrical fault in the engine coolant temperature circuit. The ECU monitors the voltage change from the ECT sensor to determine the coolant's temperature. If the ECT reads less than the expected temperature when the engine has been running for more than a few minutes, the ECU determines a fault and it sets P2185. The ECU can also set this code if the ECT sensor's resistance does not match the expected values. P0117 code. Engine coolant temperature sensors. 1. Circuit low. It indicates that the vehicle ECU has detected a low voltage input from the engine coolant temperature sensor 1. Once the ECU detects a signal voltage that's lower than the normal operating range of the sensor, the OBD code P0117 registers in your vehicle's memory. The low signal that the ECU detects from the ECT sensor can mean that the engine coolant is excessively hot. P0119 code stands for Engine Coolant Temperature Sensor 1 Circuit, Intermittent Erratic. This trouble code sets when the ECU perceives that the input signal from the engine coolant temperature sensor is intermittent or erratic for a set period of time. If the vehicle has two coolant temperature sensor, the one portion of the code points to sensor number 1. Diagnosing ECT sensors. Before starting, check what type of temperature sensor you have. With negative temperature coefficient, these are the most popular sensors used in cars. The resistance decreases with the increase of the temperature. With positive temperature coefficient, used in some older systems such as Renix, here the voltage and resistance are increasing with the raise of the temperature. You should also have a voltmeter. Diagnosing ECT sensors. Procedures for verification the functionality of the ECT sensor with negative temperature coefficient. Open the protective rubber cap on the connector of the cooling system temperature sensor. Connect the negative wire of the voltmeter to the chassis ground. Determine which are the signal and ground terminals. Connect the positive wire of the voltmeter is to ECT signal terminal. Start the engine from cold state. Depending on the temperature, voltage reading should be in the range of 2 volts to 3 volts. The relationship between the voltage and the temperature is shown in this table. So you can see the table. It should be around 2 to 3 volts, which means here in cold starts because normal ambient temperature are 20 degrees Celsius, sorry, to 30 degrees. Okay. Check whether the ECT voltage signal corresponds to the temperature. You will need a thermometer for the purpose. Start the engine and warm it to the operating temperature. During engine warming, the voltage should decrease in accordance with the values given in Table 1. Common problem is that the output resistance and voltage change incorrectly beyond its normal range. The normal value of the ECT sensor voltage is 2 volts at cold engine and 0.5 at warm engine. A defect sensor can indicate a voltage of 1.5 at cold engine and 1.25 at warm engine, thus causing difficulties of starting a cold engine, and a presence of rich fuel mixture whether the engine is warm. This will not generate any fault codes if the onboard controller is not programmed to detect voltage changes, since the sensor continues to operate within the designed parameters. If such defects is found, the ECT sensor must be replaced. If the ECT voltage signal is equal to 0, lack of power supply, or there is a short circuit to the ground. If it is 5 volts, we have an open circuit. Sensors with a positive temperature coefficient. ECT sensors with a positive temperature coefficient of resistance is a thermistor whose resistance increases with the rising of the temperature. It is used in a small number of systems, mainly in rental cars. The overall method of verification is similar to the method for checking a sensor with negative temperature coefficient, described above. Received measurements data can be compared with the data given in Table 2, showing the relationship between the resistance and the temperature sensor. Okay? So the procedure here is the same as in a negative temperature coefficient, but instead of the voltage dropping, the voltage is actually increasing, as stated here. Thanks for listening.